Hello and welcome. This session is Dynamics 365 Finance and Operations GIt and ALM, how to deliver more faster. My name is Nathan Clouse, and this is in the Latheron room at 12 GMT. I'd like to thank our sponsors, ScriptRunner, DQ Global, Proximo 3, Redspire, Agilicis, and Hitachi Solutions. My name is Nathan Clouse. I'm a technical architect for Invista Corporation. I'm also a Microsoft Business Applications MVP. Just to describe what I do, as a technical architect, I get into a lot of different things. I just sort of pulled my bio from my Twitter. I write code. Sometimes it's good. I have a blog, atomicax.com, where I talk about various things related to finance and operations and all related technologies. You can get a hold of me on Twitter if you want, at NathanClouseAX. There's my email if you'd like to reach out there. But before we get started, one of the things I like to do with every presentation that I do is to just pick like a theme that just sort of, brings everything together. And since this is a Scottish summit, I was thinking about things from Scotland that I love, along with TV shows that I love, and I'm just a big nerd. So there's only one person that I could really think of that blends science fiction and Scotland all together into one of my favorite characters of all time, and that is, of course, David Tennant as the 10th Doctor. So you'll see a lot of David Tennant and Doctor Who related things throughout the session, just sort of for fun because I'm a huge nerd. What we'll be talking about today is source control, specifically TFVC and Git, converting to Git, really getting started with how some of those things are different, and some of the really cool things you can do with automated or automation actions inside Git. So first, what is source control? It's just a system that tracks and manages your code. It's been around for ages. For finance and operations, we have two major control systems to look at. That's TFVC, or Team Foundation Version Control, sometimes known as just TFS, and then also Git. And this can be hosted with a couple different options. You can go to GitHub, you can use Azure DevOps, you can also use GitLab. We'll be focusing on the Azure DevOps experience, but you can use either one of those other systems if you'd like, especially GitHub with private repos now. They don't have a paywall, so you can certainly check those out for any private or personal things you'd like to, take a look at that you don't necessarily want to share with the world as well. But when we look at source control and ALM and how our applications are getting more and more complex, what we really need is a system that will help manage, plan, create, verify, package, secure, release, configure, monitor, and protect our source code, our configurations, our data, and everything that makes up an application. An application is no longer just, bits in a bucket somewhere. It's just code thrown out for, hundreds of developers that just bang out a bunch of code and then there's our application. There's a lot more that goes into it, and we need a system to help manage all those complexities. We'll be focusing on DevOps, but Git can help with a lot of this, especially on the technical side. So before we can really get started, we really need to address the elephant in the room, and that's that TFVC is not the most ideal system for, sort of going forward. The good things about it's supported by Microsoft. So that means if you have an issue that is a legitimate bug, you can create a ticket and Microsoft will help you out. Having said that, if you're worried about sticking with something that is supported, I would challenge you to consider, when was the last time you actually contacted Microsoft for a support issue related to TFVC? I've been working with it since it became fully supported in 2012, around the year 2013. Haven't had to file a ticket with Microsoft over anything that wasn't specifically a setup issue that we created ourselves versus an actual product bug. So if we're looking at options that are not supported, I wouldn't let that hold you up. But again, TFVC is officially supported. Next, TFVC is push-based. So what that means for non-technical people is we have developers that are committing code They're adding it to our code base, and then that's it. They're done. They don't have to make sure their code gets promoted per se. They can just throw a bunch of code out there and hope it works and it builds, and that's it. I think with modern technology, we can do a whole lot better than that. Also, your branches inside TFS sort of last forever. We'll talk about this more later, but it means that your code solution and footprint is sort of monolithic, which means you've designed a solution, and all of your problems have to fit into that solution that you've designed. You can't really make changes to it as new stuff comes up, or new developers are onboarded or offboarded, or as your project changes, or post-go live support changes, or whatever the case may be. You sort of set up your solution, and then everything has to fit into that solution. So why I think Git is awesome is we don't have some of the problems I just mentioned. However, it is not officially supported by Microsoft. That having been said, it is used internally by Microsoft. So if you talk to any of the developers in the FNO team, they'll say, yeah, we use Git. It's not supported. It's not really a problem for us. So, again, it's not supported, but I wouldn't let that necessarily, hold you back from at least taking a look at it and giving it a try. If it doesn't work out for you or your organization, you can always go back to TFVC. We know that works. We know that comes with some bad stuff that sort of just comes along with, but we can certainly try something new and see if it works better. Git is a more modern approach. So rather than being push-based, it's pull-based. So if I'm a developer, I commit code, and the end of my code lifecycle is I create a pull request, and it gets accepted or declined, and I get feedback. But either there's a start, beginning, or there's a start, a middle, and an end to the lifecycle of a developer's work, and that's a good thing, because developers have to ramp up work, do it. Finish it up, and then validate that it makes it basically to the next stage of its existence, where it gets accepted into a main branch. And lastly, branches are short-lived. You can think of branches sort of like workspaces. So you've got a problem, you're going to set up a workspace to solve that problem. You solve the problem, the workspace goes away. Same sort of thing. And in this context, I would say this is a really good thing. So if you look at something that you might see with AX 2012, this is TFVC. Along the bottom, you've got a bunch of different developer branches. Let's say I'm working as developer 1 against the dev 1 branch. I commit a change, a single change set. I want to keep that in mind. It tests fine, great. So I merge it up to dev release. That gets in front of, let's say, a functional consultant connected to some kind of test environment. They approve it. Then that gets merged, built, and released to a trunk branch, which would be similar to a UAT environment. End user says, hey, looks good, and then it finally gets merged, built against the release branch, and that would go into, let's say, your production environment. So one change got 4 different touch points. So I had to, as a developer, commit it, and then, merge it up the tree. However, one of the things that I just created that's sort of difficult to see is I just created a bunch of work, because now I have to take that one change set and merge it back down to all my other developer branches if I want them to have the same change. So, not ideal. You can potentially have someone's full-time job just being managing, pushing all this code around. So again, not ideal. This is something you might see that is TFS or TFVC related to finance and ops. It's a little bit better. We have our developer branch down here. So all developers are working against the same thing, the same repository. So any developers that commit anything, their developers will have to make sure they're getting the latest and greatest before they make any changes. That would get merged into the trunk branch, which ties to like test. Functional consultant would review it there and give it a pass-fail, and then from there go into the release branch. That would go to like your UAT environment. Client would review and approve it. you take that package, mark it as release candidate, set to yes, and then it'll be available to deploy to your production environment. But next, when looking at TFVC, so this is just a diagram from Microsoft, and I want to call out all the arrows pointing to the right is basically something I have to maintain forever. So that quickly turns into I'm maintaining 4 different versions of a bunch of different things, depending on where stuff is in the pipeline or the channel or the life cycle or whatever term we want to throw out there. This can become quite cumbersome and take a lot of work to maintain, and you basically have added a position of a build manager or potentially a part-time build manager. And I think we can do better. Next, if we look at Git, it's sort of a similar graph, but I want to call out a few things. At the top, we have our topics. Our topics can be anything from a new feature, a new change request, a new bug, a hotfix. Doesn't really matter, just there's something I need, and that's a technical effort that requires code. So you set up a new topic for that. That would be a new branch. You'd assign a technical resource to it. They do their work. They commit the results, and then the results would go into the green line, which is your main line. And then from there, you would have specific release branches that you would sort of build out, or branch off and build against. So you have those that represents what's currently in your production environment. If you have some kind of critical bug that gets discovered there, you can go ahead and develop in that specific release branch, the 2 lines along the bottom. Or you can just go ahead and make a new topic as like a hotfix or a bug, have it be merged into master or the main branch, the green line, and then it just gets rolled out and picked up in the next release. So it's a whole lot more flexible, and really you'll notice the only thing I'm maintaining forever is the green line pointing all the way to the right, my main branch. So there's a whole lot less administration overhead to keep stuff in sync. So TFVC isn't all bad. It's got a few things that some people find quite advantageous, and those are shelf sets. You can use those in conjunction with gated check-ins. So you can define a quality bar for developers, so when they check something in, it has to meet a certain quality bar. So it has to all compile, make sure they checked in everything in their project, not missed a few objects or elements. It also comes with a few policies, which can help weed out some crap commits that developers may do either just because they're in a hurry, or just weren't paying attention, just forgot something, whatever the case is. So TFVC isn't all bad. If your only option is to use TFVC, great, that'll be fine. But again, I think there's something better. Next, Git really has some good things about it as well. So the first thing is that you can work offline. So someday Microsoft will deliver the offline developer experience, so that will just be something that we can install inside Visual Studio that will have just enough so that we can develop against F&O. We won't have a database per se, we won't have a full runtime, but we'll at least have enough that we can get started working on something, and that'll be running locally. It won't require a local VHD environment image. It won't require a cloud VM. So this sort of supports the story of, you could develop on a train or a plane somewhere where you may not have good internet. Next, you do have to relocate your projects inside of your package. Some people say this is bad. I say it's good, because then now your packages imply ownership on your projects. So it's just sort of easy to see what belongs to what, especially if you have multiple packages or multiple models. We've talked about this already. We have a branching, and we do branching per work item. So when you get a new requirement, you make a branch for that requirement. People work against that requirement, commit all their changes, and then those get pulled into the main branch once everything's done and tested. Along with that, excuse me, you get sort of 2 things. The first is a pull request. So that is your developer saying this new requirement has reached the end of its development lifecycle. We need to go ahead and review it to get pulled into the next branch. And sort of hand in hand with those are code reviews. So we can see what was changed, provide feedback. We can reject that pull request and say, this isn't going to work for these reasons, address these issues. So it just sort of closes the loop on potentially more junior resources connecting with more senior resources to get better. So why is Git better? Again, it's more modern. So we've sort of talked about that. It matches how things work in the real world. So typically developers are given a new requirement and they work on that until it's done, and then they get a new one. When using TFVC, that's sometimes changing priorities can become sort of difficult. And Git with multiple branches and multiple workspaces, you can flip between the two if you need to. And that sort of ties in with the more agile. I don't want to use the word agile in any sort of project management sense, but again, if you've got competing requirements or competing changes or features, developers can shift between the two of those or three of those a whole lot easier than they could with TFVC. Again, you can meet requirements one at a time. More specifically, Git has more tools and automation and actions that will help, really drive the value of some of the automatic builds and testing that are becoming available with FNO. So, really briefly, to convert to Git, it's really simple. You make a new Git repo, make a new branch. You would connect that in your developer environment. Basically, just copy paste your code over. Add a new Git ignore file. This will let Git know what files to ignore. You typically have to do your entire package's local directory under Git source control. So you want to have it ignore all the system stuff, all the base product stuff that Microsoft ships. Next, I mentioned this already. We're going to have to relocate all of our Visual Studio projects and then just do some miscellaneous cleanup. So when moving code around, we're going to create a few change sets that TFVC will see, so we'll want to undo those. But also, once we've moved from TFVC to Git, we want to take all the TFVC stuff, mark it as read-only so people can't continue to commit code there. Next, when converting to Git, I would highly recommend that you play around with it before you just decide to go ahead and do it. Because it's a change in, if you're very used to TFVC, it's quite a change, because it's a change in how you think, but also how you work. And here's the cheesy one-liner for this presentation. With Git, we're pulling together rather than pushing alone. So next, we'll review an example of a branch with a pull request. So here you can see we have our main line along the top, and we have a new requirement called requirement 1. We create a branch for it. And here we can see the developers just committing code. This would be, just part of their normal everyday work stream. So they have their requirement, commit code, and then at the end they say, all right, this is done. I've tested it, create a pull request, and it would get merged up automatically into the main branch. So next, what is a pull request? I've got the definition there from GitHub, but really a pull request is a developer saying, I've completed my work, I need to now progress it to the next step. It either needs to be accepted or rejected with feedback, but as far as I'm concerned, I think I'm done. I need someone to review it and confirm that, or let me know I'm not done. When to create a pull request. This is very important. So once development is done and you have tested it, so I'm talking to developers right now, your code is not perfect. Sorry. My code isn't perfect. I write pretty lousy code most of the time. You need to test it, and you should have supporting test cases from an FDD or TDD to test with. To create a pull request, it's really easy. There's all sorts of different places you can do it. You can do it inside Visual Studio, inside Azure DevOps, and GitHub and GitLab if you're using those. But inside Visual Studio, you've got your Team Explorer on the right-hand side probably. Just go to create a new pull request. That'll bring up this page. and then you just click on either one of those buttons to make a new pull request. So next we're going to talk about automation and actions. There's a lot of automation that can really help out with eliminating junk before it gets to a person to determine that it's junk. And we'll talk about what that means. I can create a build request from a pull request, and that build has to complete before the pull request gets assigned to someone to review. What that means is someone says, hey, I've developed, finished developing requirement 1. I think it's ready to be, merged into the main branch. I'm going to go ahead and create a pull request. And as the developer, when I create that pull request, it's going to create a build request for that pull request before it gets to an approver to say everything in here at least builds. It at least compiles after I've merged it, done a temporary merge into main. That's really important. If anything were missed or forgotten or otherwise overlooked, this would help call that out and send it back to the developer who made the pull request to say, hey, your build failed. Here's your build report. Address these things, and then, try your pull request again. Next we can set up, they're called checks for pull requests. These are basic rules that you can set up on your pull requests to make sure that they're being met before they get accepted as a valid pull request. One that I always set up is any code that gets committed gets tied to a work item. We don't just accept code from anywhere, from anyone for any reason. It has to be tied to a specific work item, and that is a hard requirement for any pull request. If you've got any code not tied to a work item, your pull request is going to be rejected. Sorry. Next, with automated testing and for pull requests related to a build request, you can set up a build and test request. This is more of the advanced feature set to execute a build and then execute all the tests you have set up in that build pipeline against that temporarily merged code base. So let's say requirement 1 changed the workflow of how sales orders are created. Part of that, we could have advanced testing to make sure that that code doesn't change the critical path for all of our sales order testing as it relates to either ATL, sys-test, or RSAT. And last, last is you can just have automated or continuous improvement builds for commits. So when a developer commits something, we can just kick off a background build, say, this was committed, go ahead and build what was ever committed against this new branch, and let the developer know, here's some stuff that was missed, or this failed for this reason. It's more advisory, but at least it lets them know what's going on and gives them some feedback as they're working as to issues that they will have to address before their code will be accepted as part of a pull request. So here, if we take a look at an extension or an extended pull request, again, we've got requirement 1 with the developer working and committing code at the pink arrows. But what's going on behind the scenes of the blue arrows and the green diamonds is after they commit some code, we're going to kick off an automated continuous integration build and send a report to them for what was the result of that build. We got some warnings here, we got an error here, whatever the case may be. But where they're getting continuous feedback from stuff as they're working. And finally, all that pull request automation I talked about would execute here prior to it actually being accepted into the main branch. So, you can, whatever automation you set up would execute here, and that would happen before it gets to an approver or before it gets to a person to actually act upon. To set up continuous integration in your build pipeline, you'll select triggers and then go to enable continuous integration. You'll want to put a filter on whatever branch it is that you're connected to. And lastly, I always suggest that you set up a scheduled build there's an option to say only build if things have changed. See if anyone else is committing code in your branch when it's when it's supposed to be for you only. So next we have a pull request example Here we're merging from feature 1 into main. Down here you can see, so I just created this pull request a minute or two before I captured the screenshot. It kicked off a build for me against the main pipeline. Next, you can see I've got 3 checks that I want to execute as part of this, part of the automation for this pull request. And lastly, you can see it did a temporary merge. It had no merge conflicts, so if you're coming from TFVC land, this is sort of astounding because it did the merge for you, and there wasn't a lot of messing around with the comparator tool that Visual Studio ships with. So, if your merges are all happy path merges, you never have to go in there and manually merge stuff or figure stuff out. So next, we have a few examples of pull request checks. So this is what's going on for this specific pull request. I have to have a successful build, so everything has to compile before it gets assigned to an approver. My work items, my code must have work items linked to it, so I did that. And lastly, I have an optional test here to review code coverage status. For this pipeline, I didn't set that up, so that'll always fail. That's why it's marked as optional. But there are a few others that you can set up here. So there's a lot of utility and value in making sure that you only want to see stuff that passes these rules, and you can set that sort of stuff up here. Next, we're going to talk about a pull request with a merge conflict. So I set this up to specifically create a merge conflict, and we're going to review what that sort of looks like, and how this is, even with a merge conflict, this is better than TFVC. So first, we're going to be merging from feature 2 into main. So first and foremost, this is from commit feature 2. I have merge conflicts, so I was unable to merge stuff. Because I have merge conflicts, it's not going to even attempt to run a build. So, I've only got one required check here, and that is that my work items are linked, because we already have merge conflicts, so there's no point in building it because I don't know exactly what it is I'm going to build. So we'll have to address that first. So you can see it's already, because we have a merge conflict, this has to go to a senior resource. The reviewer has been assigned to me. I'm the only person in this project. But, we've got merge conflicts. So this is in the web client. I've got a conflicts tab that I can take a look at. And it takes me into something that looks very similar as to what Visual Studio would have, but this is all web-based. So you can see here's my commit that I'm all of my commits that I'm trying to pull. And then you can see here, I've got, specifically 2 lines of code that are competing against each other. And in the main branch on the right-hand side, I have, this is feature 1 that has already been pulled and accepted. And on the left-hand side, I have feature 2 right here. So in this dummy example, feature 1 and feature 2 cannot exist together. So I'll have to pick a winner and pick a loser. However, I can do that, with some of the controls here. So I don't even have to open up Visual Studio to address this merge conflict if it's a relatively easy one. I can do it in Visual Studio as well. I can pick this up and work from there. But, if it's something very lightweight, you can go ahead and do it from the web interface, which I think is really handy and useful. Next, we're going to take a look at what those different branching and pull requests scenarios sort of look like. So again, we have requirement 2 with the developer committing stuff, and then continuous integration, letting the developer know what's going on behind the scenes. Next, we get to the pull request automation, and we sort of fail our pull request automation because we have a merge conflict. So I as the more senior resource, take a look at the merge conflicts, see that I have an issue, and I have to decide, a winner and a loser. So in this instance, I'm going to say, hey, I'm not going to accept your pull request. I'm going to go ahead and abandon it. And lastly, I've determined that requirement 1 and feature requirement 2, can't live in the same code base. So at the black arrow here, I'm saying, all right, sorry, but we're going to have to go ahead and delete this branch. So, thanks for working on requirement 2, but it's incompatible. So we're going to get rid of the code. And that's sort of where the requirement 2 branch ends. So next, when we look at branching and resource management, you can see here we've got a lot of different things going on. We've got bug 1 along the top and then 3 requirements along the bottom. But because we're setting up a workspace for sort of each work stream, what we can do is if I start adding boxes for this, and the blue boxes, this could be one developer on one development machine, flipping between these 2 branches with no problems. So if you're used to TMVC, that's semi-amazing. But also, I could have another developer in the red boxes here working on something else on their own machine. Again, they're switching between their own branches, so their own workspaces for those. So I'm not having competing issues or contention related to, this feature is half done by this one developer over here. And it's in the same code repository, so now I've got to start cherry picking specific change sets. None of that happens. I set up a branch for requirement 1. It gets developed. It gets to the end of its development life cycle, and I pull it into my master/main branch. However, if you only have one resource available, that'll work just as fine. So they can have one development resource working on one development machine, and as long as they're sort of staggering their commits and switching between their branches, you could have one person working on all of these different things at the same time without stepping over top of anything they've worked on before. So again, a lot of utility there, and you don't have to worry about competing priorities or anything like that. Next, we're going to talk about build and test. There's a few different ways that you can set up builds, and the first one is with systest. So these are automatically discoverable, and they're built into the build template. I want to be very specific here. This is the cloud-hosted build tenant or build template. So if you're using the serverless pipelines, that is not included. The serverless pipelines will basically do just a quick compile to make sure that all the code is there and it passes a compile, and it'll give you feedback on best practices and that sort of thing. But in order to use systest, ATL, or RSAT, you will need a machine that has a full host of options, including a database and basically a UI for users to log into. Next set of tests that you can set up is ATL, or the Acceptance Test Library. This is just sort of marketing stuff for Microsoft. They're consistent, discoverable, and performance-oriented. One of the great things that ATL really started delivering is an easier way to develop tests without having to generate a bunch of specific data. But also Microsoft started shipping their ATL tests in the base product, so you can see how they're doing it. So there's a lot of great code out there for how to build your own ATL test library for anything that you've customized, or take stuff that Microsoft has already done and add onto it via extension, or just copy and paste it and make it do whatever you want it to do. So a lot of utility there, a lot of really great things. When we start talking about tests, so this is a slide from Microsoft. I couldn't tell the difference between the two of the colors there, so I added some numbers. But when we look at the number 1, those are our sys tests. And they have a quote-unquote sweet spot. But really, a sys test is a unit test. When you start getting into more complex testing, like ATL, that is a component test. And then finally, RSAT is sort of the more complicated and user-driven testing. available. But you can see sort of in that pyramid, we've got a tool that covers one or more major area of that pyramid. So if we really want to invest heavily in testing, first we'll need to make sure we're developing the right kind of tests, but also those that diagram helps us diagnose where what tool we should be using for what type of test. Next, we've got setting up automatic releases. We're going to focus on the Azure DevOps experience here, but I'm sure you could set this up with other platforms. If you want to release something to LCS, you can have Azure DevOps orchestrate that, send it off to your build server or your build service. That will give you a deployable package that can then be sent from Azure DevOps to Lifecycle LCS or Lifecycle Services using a release. And it'll just take that and store it in your asset library like you manually uploaded it. It's easy to select from. It just picks the name that you set up in your build pipeline. So sort of really easy, and just I'd advise that you set this up. Next, if you want to take it a step further, you can set up a release from LCS to a UAT environment or any standard environment type. As some of you may already know, our build boxes are going away, so standard offering is now just a production environment and a standard acceptance test environment. But if you added or purchased an additional SKU for any standard environment type that is hosted inside LCS, you can use this sort of automation to deploy a code package automatically from a successful build. Next, we're going to get into this is sort of a marketing slide from Microsoft, where we're calling this the new feedback loop, where we have an engineer that's using Visual Studio and Azure Azure DevOps repos like Git, along with test plans and pipelines to start delivering high quality, consistent code that will just get automatically deployed to a web application, and we'll use Azure Insights to gather feedback and telemetry and have that go back to the engineer. And then lastly, number 8 with the boards, that's more of an implementation life cycle. So where an engineer is getting new change requests or new features are being assigned to them, and then it goes through that same life cycle. So for F&O, not all of these pieces are here. In fact, more are missing than not. But you can sort of see where we're going based on our service offerings and availability from AX 2009. Then sort of it got a lot better with 2012, and it's continued to get better with each release. So this is the direction that we're headed, and I think Git is central to that story because it has a lot of the tools as it relates to automation, telemetry, and just getting rid of a lot of side work and busy work to help your engineers stay focused on delivering features and requirements rather than tracking down, where's this change set in TFEC. And finally, this is sort of the same thing, just a little bit different. We're going to be focusing on, release, deploy, operate, monitor, plan, code, build, and test, and then that's sort of a never-ending loop. And because we're working, we're focused on delivering a lot of value for our customers, we want to sort of fully embrace that life cycle, and Git is sort of central to making that happen. So thank you for listening. My name is Nathan Clouse. This session will be available on YouTube in approximately 14 days, and my slide deck will be available very shortly after this presentation. So thank you. Hey everybody, this is one last minute edition. Just want to include some sources. I've written various articles on all the topics discussed here today. So I thought I'd link those and also throw up my contact info again in case you want to reach out or have any questions or concerns. Always feel free to reach out. Thank you.